All right, day 4, block 2. We're classifying triangles by angles and segments. So this should be a pretty easy set of notes. We'll have some proofs at the end, but we're going to start with some vocabulary here. So it says you can classify a triangle by its angles and sides. So this first group of vocabulary terms, these are all the ways you can classify by angles. Down here, these are the ways we classify by sides, meaning the side length, and how many are congruent to each other. So our first angle classification is equiangular. That means that all the angles are congruent. If we think about what we know about triangles, the angles should add up to 180 degrees. If they're congruent, that means they're the same. So if we divide it by 3, the 3 angles in it, that means an equiangular triangle always has 60-degree angles for all 3 measures every single time, no matter how long the sides are. Acute means all the angles are acute. That's less than 90. So all the angles are less than 90 degrees. Right means that it has one right angle. Obtuse is one obtuse angle. So that is only one angle that's greater than 90 degrees. Okay, it can only have one that's greater than 90 degrees. It can't have any more than that. Otherwise, the 2 angles together will sum to bigger than 180. Then there's no room for the 3rd angle. Our side classifications, equilateral, all sides are congruent. Equilateral will always also be equiangular. Those will always be the same, like they'll always go together. Isosceles means at least 2 sides congruent. So really equilateral is like a special case of isosceles because the 3rd side's also congruent. But typically we're looking at 2 sides being congruent. Another fact with isosceles triangles is that the base angles are also congruent, meaning these 2 angles down here. Whoops. So they're the angles across from the congruent sides. Base doesn't always mean bottom. Right, so it's tilted on its side, but it's the 2 angles across from the congruent sides are congruent to each other. And then scalene means no sides are congruent. So this might be 5, 7, 12. Right, none of the sides are the same. Okay, so now you have all the vocab. See if you can classify some on your own. So I want you to try number 1, 2, and 3 here. Let me scroll down a bit. So you're going to circle the acute triangles, scalene, and obtuse within each set. So try those on your own and then see how you did. All right, so here are all my circled triangles. Acute, remember, that means all of the angles are less than 90. So these are the 3 that work. Remember, this equilateral triangle means that all angles are 60. So that would also be acute. Circle the scalene, that means no sides congruent. So I don't care about the angles here, I'm just looking at sides. The first and the last are both scalene. And then number 3, we're getting into a combination. So obtuse isosceles. Obtuse means one angle that's greater than 90. That's terrible grammar there. Isosceles means 2 congruent sides. Whoops. So both things have to be true in order to circle that triangle. The first one is isosceles, but is not obtuse. Okay, the second one is obtuse, but not isosceles. The third one is neither of those. So, or sorry, the fourth. The ones I circled, I have my obtuse angle, and I have my congruent sides. Obtuse angle, congruent sides. Okay, so those 2 got to be circled. Next up, we're classifying. So now we're going to give it a name by its angles and its sides. So I want both terms here. Typically, when we write the names, we usually write the angle term first. I wouldn't mark it wrong if you did the other way, but typically we say the angles first. So when I look at these 3 angles, they're all less than 90, making this an acute triangle. And I have 2 congruent sides by my labeling here. The lines mean congruent. So it is isosceles. Okay? Acute isosceles triangle. Try the second one on your own. That second triangle is an obtuse scalene triangle. One angle greater than 90. All three sides are different. All right. Couple other things to think about. Number 5, can you draw an obtuse right triangle? Think about that for a second. Can you draw an obtuse right triangle? That means that you would have to have one angle that's greater than 90. So let's take the smallest possible, 91. And you would have to have an angle that's 90 degrees. Those two alone equal 181. So that would not be possible. Okay, an obtuse angle has to be more than 90, it cannot equal 90. So no, we cannot draw that type of triangle, right? Because there's no room for the third angle. Number 6, can you draw a right isosceles triangle? So that means I'm trying to draw a right angled triangle with two sides that are the same. Oh, one thing I can show you on Kami is if you want to draw a triangle, if you go over to the Shapes tool, click the triangle, and then it says at the bottom, Shift will draw a right triangle. So I hold down Shift, and it draws a triangle. It even shows me the angles, which is kind of cool. So I have a nice triangle there. There's my right triangle. If I want it to be isosceles, that means two sides have to be the same. Now, we haven't talked about this yet, so I'll kind of just tell you here. So let's say they're both 5. We're going to use Pythagorean theorem coming up here soon to figure out that missing hypotenuse. In this case, it's root 50. Don't worry about it if you have no idea how I got that. We'll show you eventually. So this is an example. Yes, I can. I just did. This triangle is isosceles. These sides are the same. And this is our hypotenuse, so we're good. Okay, circle all the equilateral triangles. Try that one on your own. All right, here are my 3 circled triangles. These two, or this one's easy, 999. These two down here, this one is using our symbols, equal, and then equiangular is always also equilateral. Okay, so those 3 are equilateral triangles. All right, next section. For each statement, circle always, sometimes, or never. I want you to try these, read through them, see what you think. No big deal if you're not totally sure, and then we'll go through. Okay, so let's talk about these. Part A, right triangle is isosceles. So we showed the example above where that can be the case, but there's definitely examples where that's not the case. Right, there's a clear one. Those are definitely not congruent. So, sometimes it's true. Part B, an obtuse triangle has 3 obtuse angles. It can only have one. We talked about that at the beginning very briefly. So this is never, because if it has more than one angle that's greater than 90, there's no room for the third angle, so never. And lastly, an equilateral triangle is isosceles. This is kind of sneaky. I said it really, really fast at the beginning of the video. Isosceles technically means at least, 2 congruent sides. So equilateral is a special type of isosceles triangle. Not the biggest deal in the world here, just kind of a sneaky one there. Okay, so let's look at some algebra and then some proofs. I'm going to do one of these with you, and then you'll do one on your own here. Just thinking about what we know now about these terms and how we can combine it with algebra. Finding x and the length of each side of triangle ABC, if triangle ABC is an isosceles triangle with AB congruent to BC. So let's label AB congruent to BC. The dashes mean they're congruent to each other. So right away that tells me, why don't I set these guys equal? If those sides are congruent, those expressions are congruent. So I'm going to subtract 2x, and I'm going to add 3 at the same time. 2x equals 8, therefore x equals 4. Lastly, I just need to plug in my values. 2 times 4 plus 5, 8 plus 5 is 13, so that's BC. 4 plus 2 is 6, that's AC. And 4 times 4 minus 3, which is 13. Okay, and that's just a good way to double check here that these are congruent as well, plugging them both in. I know they should be the same, but good double check. So try number 2 on your own. All right, so here you go. I got x equals 9. I set these two sides equal. It doesn't matter which two you pick because it's equilateral, so you can pick any pair that you want, solve for x. I plugged them all in just to double check that I found x correctly. They all equal 37, so I'm good. All right, lastly, we have 2 proofs. I'm going to do the first one with you, and you're going to try the second one completely on your own. Okay, so as always, statements are on the left, reasons are on the right. Angle 1 is congruent to angle 4, should always be first. And that is because it is given. And then I want to see, okay, let's label angle 1 is congruent to angle 4. I'm trying to show that triangle ABC is isosceles. So there's 2 things that make an isosceles triangle. It's either because there are 2 congruent sides or because there are 2 congruent angles, okay? So what I noticed right away is that I have a straight angle between 1 and 2, and then another straight angle with 3 and 4. So straight angles tell me that angle 1 is supplementary to angle 2, and angle 3 is supplementary to angle 4. That is the definition of straight angles. Okay? So I'm just kind of working my way up to either 2 sides congruent or 2 angles congruent. So, based on what we've done in the past, I know that if 1 and 4 are congruent, that has to mean that 2 and 3 are congruent. And the phrase we used for that was that supplementary, or supplements, sorry, I always abbreviate it, supplements of congruent angles are congruent. Okay, so now that I know 2 and 3 are congruent, based on what we've talked about today, I can already conclude ABC is isosceles because the definition of isosceles, and that's all you have to say. You don't have to like write a novel for the reasons. We know that it means it's isosceles because the angles are congruent, which we've shown. Okay, see if you can do the next one on your own. You're going to use more thinking from our parallel lines. So alternate interior, alternate exterior, corresponding, those kinds of thoughts will help you do the next one. All right, here's my final proof. So again, always start with the given statements. I'm trying to show that triangle ABC is isosceles. I notice that if the lines A, D, and CB are parallel, then I have some pairs of alternate interior angles. The given statement told me that angle 4 and angle 5 are congruent, so I can use the transitive property then to show that angle 1 and 2 are congruent. If you put substitution here, that's fine as well. Those ones sometimes are interchangeable in situations like this, so I would take either reason. If angle 1 and 2 are congruent, then the triangle is isosceles from our definition of isosceles, and we're done.